S-curve, if you go and look what a sigmoid looks like, it's going to be something similar, all right? Because what you're doing is you're utilizing the power of that sigmoid function to really give a good landscape to the neural network for the solution. So as you can see, as we increase the number of iterations, this is a logarithmic graph. So that's why it doesn't look even spaced at the bottom and the x-axis. But as you can see, as we increase the number of iterations, the error became smaller and smaller and smaller, which is what we were trying to achieve. Okay? So that's what neural networks are doing. They're trying to reduce that error, and they're trying to adjust those weights and biases to feed your solution, to come up with an answer.
We don't have too much more time, but so you're saying that the red was the average, or that was
No, the red is the prediction.
Got it. And this is got it. And then you try to trade it, and the trading would get this much better.
Right. This is giving you a visualization of what the training was like for that particular neural network. So when you run the samples, you're going to see those two curves. You're going to see some kind of visualization, and you're going to see something that will show you what the neural network is doing during training.
Over there, because I probably meet up, did you show us, because we have to almost wrap it up, did you show us where to get these, the examples and to,
Yeah, it's in the GitHub repository.
we know how to run it?
Yes, I showed.
Do you see that?
Did everybody get?
That's okay, that's good.
Yeah, there is a README. So we don't have time for another example?
I mean, how long will it take? 10 minutes?
5 minutes. 5 minutes.
Is it okay with that?
Yeah.
In terms of the training, thanks. In terms of the training, is that computation going to be the same? Or is the only thing that's going to make that different is changing like the weights and things like that, or is that computation going to be predictable every time you run it?
You never change the weights. You change the hyperparameters. So the hyperparameters are like the number of hidden layers, the number of iterations you want to go through, the error rate that you're willing to put up with. Those hyperparameters are the ones that are going to change what your neural network is going to train like.
And then, but when it's training, each iteration is each iteration, is the computation like, are the results going to be different every time you run it?
Yes.
Oh,
it is, because it's going to iterate through every, you have one data set, right? Let's say that you have 500,000 samples, right? It's going to train over and over and over
right.
that data until the error rate is whatever you're comfortable with.
Right, I guess my question though is, like, so let's say you run it through 500,000 iterations, whatever. Then tomorrow you run it on the same data set, you run it all over again. Is that training going to be the exact same? Like, is it using any kind of random?
It will be very close.
Okay, that's what I was wondering.
Yeah, it will be very close.
Cool.
Yeah, that's the whole point of saving the JSON file that I show you. Once you train it, you can just run it in a bunch of data you don't know anything about.
Yeah, basically what I mentioned to him was that you could save that trained model and you don't have to retrain it every time.
Right. So for example, I have a neural network that I trained, and I put it in a web app, right? So here's there is my neural network. Okay, you can see right there. I'm gonna make it bigger. There is my neural network in that app directory, and then Okay, and here is my web app, right? So here is my web app. It's saying it's kind of like React, but it's a web app. It's a web component. Okay, it's using Polymer. Is going to allow you to select a color based on brightness, and so but the important part about this example is what I show you, that I have a neural network available, and now I'm going to use it in my web app to predict something. Okay, so it shows you that it's powerful because you can embed your neural network after it has been trained, and then run it on your web app to do all kinds of cool things. So,
Before we go to the next sample, do you want to take some questions just in case people are too?
anybody has any questions?
Just the like, what kind of a average amount of sample data? Like, is there like, does it vary by problem? Like,
Yes.
is there a normal rule of thumb? Like, oh, you should have 1,000 or 100,000 samples.
It varies on what kind of problem you're trying to solve. Like I said, it's kind of like time consuming, because you gotta play with the amount of data you have. You gotta be able to look at those hyperparameters and try to figure out, it's fun sometimes. You're just trying to play with the parameters and trying to see how the algorithm gives you an answer that is satisfactory. So the next example is a classic example, and but it's simplified vastly, and is reading of numbers. Okay. So in this example, you'll see that I have I created these ASCII code numbers. All right. And what it's doing is that it's normalizing the number. So it's converting that number into a vector form, okay? And the vector form is simply saying, if there is a hash, put a 1. If there is a space, put a 0. So I'm converting this into an array, okay? Each one of these numbers. And then I'm creating some almost numbers, okay? So, is that? No, that's not mine. Oops. So I'm converting that into, I'm also going to feed it some almost numbers, okay? So it's almost a 9. You can see some pieces of it are missing. That's almost an 8, almost a 7, all right? So what I'm trying to do is I'm going to train the network, and I'm going to say, after you train, can you guess correctly what numbers these are? Even if those asterisks, even if those hashes are missing and there are blank spaces, okay? This is equivalent to the image problem, right? But instead of doing it with images and having like thousands of pixels, I'm simplifying it and having it with a 49 element array, 7 by 7 pixels thing, okay? So in this case, I'm using a different activation function, one called leaky ReLU, okay? And you can explore more about that, but changing the activation function can yield better results sometimes. And then in this case, I gave it one layer with 20 neurons in it. And I use the same train function. And the whole idea here is that I'm going to feed it, I'm going to train it, and then I'm going to feed it, and I'm going to see if it's going to, and then I'm going to run it, and I'm going to see if it actually predicts the right number, right? NPM. Okay? So you can see now in this output, you guys can see it? Okay. So you can see in this output, in this input, that I put 0, 1, 2, 3 to 9, and then I gave it almost 6, almost 7, almost 8, and almost 9. And then the system came up, and you can see that it correctly predicted 6, 7, 8, and 9 out of the almost 6, almost 7, and almost 9. You can go home and run it, and you'll see what more clearly what I'm talking about. But basically, that gives you 4 examples of how to use neural networks. And there is like 15 or 10 more there for you. So, huh? Yes. Any questions? Yes. So this one is a little bit different in the way it trained. You can see it went to 200 iterations. That signifies the error reduction. So what is happening is that, it's just the closer you get to the error that you're trying to the error that you're comfortable with, then it's going down. It's just 200 iterations it took to do that. And you can see the error on top. So let's say in this case, the amount of sample.
One chance. Any other questions? I'll run over. Okay. Hold on.
To try to detect that? Like the amount of data that you had to train, does that affect how many iterations you might go through
Definitely.
to like get to your
Yes.
threshold of
Yes.
your error? Okay.
So, but it could be adversely, or it could be positive to high. But the more data, in general, the more data you have to train with, the better off your output is going to be.
I'm just curious, how did you decide? I mean, so in the first example you used 2 neurons, and the other one you used 20. What's your thinking of how many neurons you're going to use?
So I start with a number of data points. So in this case, I have 49 data points in my vector, because it's a 7 by 7 pixels number, right? So I said, well, I'm going to start with half, to start with and see what it does. And I try different activation functions, and it's playing with those hyperparameters. That's the key. Are we good?
Could we get a view into some of the functions you wrote for either the read numbers or the HP versus miles per gallon?
Like the normalization functions?
Well, like the functions that are basically passed through the neural network. Right, like so with the neural network.
You want to see the code for BrainJS?
No, basically the functions that the data is passing through.
For the numbers example?
Right. So you have those 3 layers, right? The input, output, and there's a hidden.
Well, you don't pass at any functions. You adjust you adjust the hyperparameters, and the functions are going to be generated by the framework. So it's going to start, like for the weights and the biases, it's going to just be random all over the place. And then as it is trying to find the minimums, the gradient, right? That's why it's called gradient descent. As it's trying to find the minimum error, it's going to start adjusting through the process of backpropagation. It's going to start adjusting those weights. If you want to see the output, the neural network that came out,
No, I was.
because that is the function actually. Think about neural networks as a universal function approximator. That's what it is. right? So it's a bunch of little functions being composed to solve this big problem that you have, and it will approximate as best as it can to try to match whatever you told it the output should be.
Thank you.
Yep.
Any other questions?
When you mentioned on this one, when you pick 20 or the hyperparameter, is there a way? Is there like something built into the framework to help actually like train the training, so that it picks the parameters for you, all that kind of stuff, and then kind of gives you information, or you have to literally tweak it manually?
No, it's really a manual process. It's a manual process. That's the easiest to find the hyperparameters. It's not that hard.
So it's always like a hybrid.
Right. Then the hardest thing is to come up with your question, what you're asking, and then understanding and getting the data to accommodate the fact that you have to feed it vectors. So vectorizing the data and normalizing the data. That's the tedious amount of work. And then spending the time setting up the hyperparameters and seeing what comes out.
Any other questions, guys? Geovanny, so right now, guys, I have to apologize. We had, apparently I talked bad and Alexa was listening. Meetup.com right now, it does not work. I'm not kidding. If you go to our website, all of a sudden, this event hasn't happened.
Oh, man.
But can you give us perhaps your Twitter account so we could see these links for the slides?
You can go to GitHub and go to GOSP, and you can find a project called Hello Brain, hello_brain, and that's where everything is.
I'll make sure that if you go to slides.bocajs.org, give me 15 minutes after the event has finished, you'll be able to go see Geovanny's slides exactly as you're seeing. At the very the last slide will be a link to the examples. Follow what he just said if you listened in, and then you'll be able to see it. But just give us about 50 minutes after the sort of tonight, or I don't know, 9 o'clock, and we'll make sure to have it out there, okay? So sorry about that. Looks like everybody's listening on that. I just have, so if you do have any questions, definitely look us up. You will have the event if you don't see it right away. Can I open up a new tab for the winning?
Sure.
So if you guys will want to go to win, as in WIN, I want to win something, .BocaJS, as in the group that you're in, .org. All right, so one of you guys always does this and reads the URL at the top. Do not read the little tiny URL at the top. Go to this website, not what you see up there, win.bocajs.org. As you get it on your phone or your laptop or both, don't do both, please. You guys will see the numbers come up there. If it doesn't, don't worry about it. They are out there. So I'll give it some time for everybody. You can join as well. We're giving away is a 1-year subscription to JetBrains, any product you want in there. I'll give you a little bit of a hint. Once you do, 1 year does expire, the app will not stop working. You will simply stop getting updates, which probably means you'll be able to use it for the next 5 years without any problem.
Cool. Well, I just want to say thank you to everyone for being here, and just go to my GitHub, and if you have any questions or anything, just leave some comments, open an issue or something, and I'll be able to, make sure to answer those questions there.
Can we have a round of applause for
thank you.
Geovanny, please? My apologies, Geovanny. I got so flustered by this what's going on in there, I forgot to thank you. Thank you very much for a great presentation. Lewis was all the way. And like I said, definitely follow Geovanny on his GitHub. If you go to slides.bocajs.org, a little bit, about 15 minutes, you'll be able to see his information, all the things that you saw today. And if you go to youtube.com/bocajs, you can also see it there. All right, does everybody have a ticket? Perfect. We'll go ahead and lift up your phone, look at it, and one of you guys have you done yours? Well, let's type it, win.bocajs.org. So we had a hackathon. Robert, did you see that? So in hackathon, it was a contest. I'm sorry, no, not a hackathon. It was a hunting contest, and we had a cute little group. Our group won, and then all of a sudden, and it's a piece of paper. Congratulations, your group won. Wonderful certificate. Hangs on top of our group's door. Pretty much they won because of me, but don't worry about it. And then all of a sudden, one of our members won the grand prize, an Apple Watch. I don't know about you guys, but I prefer the Apple Watch to a piece of paper, even though it's a very cool piece of paper. And she got disqualified because she already won part of the group one. It's like, no, you want a piece of paper for the group, this is an Apple Watch, you should get it and all that. So they argued and she didn't get it. But here the speaker is allowed to win. Some of you guys, if you guys do win and you have received it, you're welcome to give it to somebody else in the group. By the way, the sponsors are allowed to go in there as well if you want. Or to your friends, or to anybody else, and just let me know and we'll have another winner come in there. All right, so if you guys want to look at your phone, we have a winner. Who has number 2? No one? Going once? Going twice? I did 2 tests. I did do number 1 usually. No one? Really? Nobody has the number 2 on their phone? All right, we are gonna need a new winner. We have another winner. Anybody have a 4? Whoa, does it say 4? Oh yes, it even has a pop-up saying you won. All right, guys. So again, next month, it's in December. Ignore the note that said this was the last event today. It is not. That was me copying and pasting too hastily. There is another event in December 4th, just like November 4th. It is a Wednesday. It's just before IT Palooza. If you guys are interested, if you buy a free ticket to if you buy a ticket to IT Palooza or do that thing where you bring in 2 toys, you get your chance for free to see that gentleman over there give you from basic to 100%, or 0 to hero, I believe it is, JavaScript. So it's a JavaScript workshop that gets you up to date. You won't even have to come back next month because you'll know everything JavaScript. Okay? See you guys next month.